Hello students and good morning. So now I am doing class for class 11. So this is the continuation class, and in the last online class also we were doing this same topic, trigonometrical ratios of associated angles. So today also we are continuing the same chapter. Okay, same exercise 3 4 mark section. This is page number 125 from the book Higher Mathematics for class 11 by SN Day. So now let's start this number, that is question number 6, and in the last online class we did question number 5. I hope you have understood all the problems that we did so far. Try to revise it. If you have any problems, then you can ask me or you can call me. Okay, so this is question number 6. So question number 6 is, if A comma B comma C, all are capital letters here, are the angles of a triangle, so that number 1, sine B cos of C plus A plus cos B sine of C plus A is equal to 0. So with the help of the given condition, you have to prove this left hand side is equal to 0. So in the question it is given that A, B, C are the three angles of a triangle, and you know that if A, B and C are the three angles of a triangle, then the sum of the three angles of a triangle is 180 degree, or in terms of radian it is pi. Okay, so let us write here first of all what is given here. Since A, B and C are the angles of a triangle. Okay, so what can you write here? Sum of the three angles of a triangle is equal to 180 degree, or you can write it in terms of radian, that is A plus B plus C is equal to pi. Okay, now on the left hand side there is C plus A and there is C plus A. On the left hand side there is C plus A. Let us find out the value for C plus A, or this is C plus A is equal to pi minus B. So it is C plus A is equal to, this is your pi minus B. Okay, now let us write down LHS. So what is LHS here? It is sine B cos of C plus A plus cos B, then sine of C plus A. Okay, now let us put the value for C plus A. What is the value for C plus A? It is pi minus B. So which is equal to sine B, it is cos of, what is C plus A out here? It is pi minus B plus cos B, and sine of, what is C plus A? It is pi minus B. So which is equal to, this is sine B into, now what is the formula for cos pi minus B? So you know that pi minus B lies in the second quadrant. In the second quadrant cos is always negative minus. Since this is 180, 90 into 2, that is even multiple of 90. So cos remains as it is, that is minus cos B. It will not change. Okay, plus cos B into, now what is the formula for sine 180 minus B? You know that 180 minus some angle lies in the second quadrant. In the second quadrant sine is always positive, and here sine remains as it is. Since 180 degree is 90 into 2, that is your even multiple of 90. So sine remains as it is. So it is sine B. Is that clear? So which is equal to minus, this is sine B cos B plus this is also sine B cos B, and both of these will be cancelled, which is equal to 0. So it is proved. We have proved that LHS is equal to RHS. So I think you have understood it. So you can copy it. Now we'll do the next problem. So now we'll do the next problem, that is 6 number 2. The question is given is the same statement out here, that is Question number 6. If A comma B comma C are the angles of a triangle, then you have to prove that this is number 2. Tan of within bracket A minus B by 2 is equal to cot of within bracket C by 2 plus B. You have to prove this LHS is equal to RHS. Okay. So now let us prove this LHS is equal to RHS from the given condition. Okay. So now in this case you have to prove tan of A minus B by 2 is equal to cot of C by 2 plus B. You have to express this A minus B by 2 in terms of C by 2 plus B only. There is no term containing A. So from the given condition, you try to find out the value for A only. So if you can get the value for A in terms of B and C, you may prove this LHS is equal to RHS. Is that clear? So here, since A, B, C are the angles of a triangle. So we can write here sum of the three angles of a triangle is 180 degree. You know that, isn't it? So it is A plus B plus C is equal to 180 degree. And let us get the value for A in terms of B and C. That is A is equal to 180 degree minus B minus C. Because you have to express A minus B by 2 as C by 2 plus B. And there is no term containing A on the right hand side. That's why you get the value for A, which is equal to 180 degree minus B minus C. So now let us write down left hand side. Tan of A minus B by 2. So which is equal to tan of, what is the value for A out here? It is A is 180 degree minus B minus C, then minus B whole divided by 2. Okay. So which is equal to tan within bracket. So it is 180 degree. This is minus 2B minus C divided by 2, bracket closed. So I think you have understood it. Okay. Now let us separate the term here, which is equal to 180 degree within bracket. Let us separate the term. It is 180 degree by 2 minus, it is 2B by 2. 2 will be cancelled. You will get minus B. Okay. And then minus, this will be C by 2. Minus C by 2. Is that clear? So let us take minus common here. Is equal to tan within second bracket. What is 180 by 2? It is 90 degree minus within bracket. It is B plus C by 2. Is that clear now? So now you know that this is the formula tan 90 degree minus theta. What is tan 90 minus theta? It is cot theta. Here you can take this B plus C by 2 as theta. What is tan 90 minus theta? It is cot theta. So here it is cot of B plus C by 2. So it is proved, isn't it? That is cot B plus C by 2 and C by 2 plus B are the same expression. So we have proved it. So you can copy it. I think you have understood it. So now we'll do the next problem. So now we'll do the next question, that is question number 6, number 3. The question is again here also, if AB and C are the angles of a triangle, that means you can write A plus B plus C is equal to 180 degree. You have to show that this is number 3. Cos A cos C plus cos of A plus B into cos of B plus C whole divided by cos A sin C minus sin of A plus B into cos of B plus C is equal to cot C. You have to prove this LHS is equal to RHS. We'll do this one here. Now this number 4 will be a homework, right? You have to prove this LHS is equal to 1. You can prove it. Okay, so the given condition is the same condition out here. If A, B and C are the angles of a triangle, then you have to prove that this result, that is tan of B plus C plus tan of C plus A plus tan of A plus B whole divided by tan of pi minus A plus tan of 2 pi minus B plus tan of 3 pi minus C is equal to 1. This is your homework. That is, you have to prove this left hand side is equal to 1. So let us do this problem out here, number 3. So here also what is given? So you should write A, B, C are the angles of a triangle. Are the angles of a triangle. Okay. So what can you write from here? That is, the sum of the three angles is equal to 180 degree. So A plus B plus C is equal to 180 degree. So from here you have to get the values of both A plus B as well as B plus C. So here we have A plus B, here we have B plus C. Get the value of both this expression. So therefore, what is A plus B here? It is 180 degree minus C. That is your number 1. And next one is you have to get the value for B plus C, right? So it is B plus C is equal to 180 degree minus A. So this is number 2. So let us put these values of both A plus B as well as B plus C on the left hand side. So what is left hand side here? Let us write. So here LHS is equal to, it is cos A cos C plus cos of A plus B into cos of B plus C. This is your left hand side. So this whole divided by, we have, what is there in the denominator? It is cos A sin C minus this is sine of A plus B, right? This is sine of A plus B into cos of B plus C. Cos of B plus C. So now let us put the values of A plus B as well as B plus C. So which is equal to, this is cos A cos C, right? Plus cos of what is A plus B? 180 degree minus C into cos of what is B plus C? 180 minus A. It is 180 degree minus A. This whole divided by, in the denominator what do we write? It is cos A sin C minus sine of what is A plus B? 180 minus C. It is 180 minus C, and cos of what is B plus C? It is 180 minus A. So I think you have understood it. Okay. So let us simplify it. So which is equal to, so in the numerator we have cos A cos C. It is, this is your cos A cos C, right? This is cos A cos C. Next, what is cos 180 minus C? So let us write here plus within bracket cos 180 minus C. 180 minus C lies in the second quadrant. In the second quadrant, cos is always negative, minus. And since 180 is even multiple of 90, that is 90 into 2. So cos remains as it is, that is cos C. So it is cos C. Okay. And what's about this cos 180 plus A? That is also minus cos A. That is also minus cos A. So whole divided by, in the denominator it is cos A sin C. It is cos A sin C plus, it is not plus, it is minus out here. This is given as minus. Now what's about this sin 180 minus C? Sin 180 minus C. What is the formula? 180 minus C lies in the second quadrant. In the second quadrant, sin is always positive. So positive, usually we don't write it. And since 180 is even multiple 90, so sin remains as it is. So it is minus sin C. It is minus sin, it is only sin C. Sin 180 minus C. What is the formula for sin 180 minus C? It is sin C. And what's about cos 180 minus A? It is minus cos A. It is minus cos A. So I think you have understood it. So let us simplify it, which is equal to, this is cos A cos C minus into minus, plus this is also cos A cos C, this whole divided by cos A sin C, cos A sin C minus into minus, plus this is also cos A sin C. This is also cos A sin C. Okay. So now we can add them. What is cos A cos C plus cos A cos C? That is 2 cos A cos C. You can add them, 2 cos A cos C divided by, in the denominator, what is cos A sin C plus cos A sin C? That is your 2 cos A sin C. That is 2 cos A sin C. So here also 2 gets cancels. Cos A gets cancels. What is cos C by sin C by formula? It is cot C. So it is done, proved. So which is equal to, that is your right hand side, which is equal to cot C. Okay. So this question number 4 will be a homework. You can do it at home. From given here is ABC are the angles of a triangle, same given. So A plus B plus C is equal to 180 degree. From there you can get the value for B plus C, C plus A and A plus B. Put those values in the numerator, and in the denominator you can use the formula. Okay, so you can prove this left hand side is equal to 1. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 7, number 1. So the condition given here is, if A, B, C and D are the 4 angles taken in order of a cyclic quadrilateral, then prove that number 1, tan A plus tan B plus tan C plus tan D is equal to 0. Okay. So what are these A, B, C and D? A, B, C and D are the 4 angles of a cyclic quadrilateral taken in order. So first of all, you should know the meaning of a cyclic quadrilateral. What is a cyclic quadrilateral? You know that in class 10 you did a theorem. The opposite angles of a cyclic quadrilateral are supplementary. What is meant by it? What is a cyclic quadrilateral? A quadrilateral inscribed in a circle. You draw a circle first. You draw a circle with the center O. This is the center O. And you draw the quadrilateral inside this circle. You draw the quadrilateral inside this circle. Suppose the quadrilateral is A, B, C, D taken in order is a cyclic quadrilateral. That is, the quadrilateral ABCD, which is inscribed in a circle with the center O, is known as a cyclic quadrilateral. And you know that in case of cyclic quadrilateral, the opposite angles of a cyclic quadrilateral are supplementary. So what is meant by the opposite angles of a cyclic quadrilateral are supplementary? That is, the sum of the opposite angles of a cyclic quadrilateral is equal to 180 degree. 2 angles are said to be complementary to each other if the sum of the 2 angles is 180 degree. If the sum of the two angles is 180 degree, then the angles are said to be supplementary to each other. So if the 2 angles are complementary to each other, then the sum of the 2 angles is 90 degree. If the sum of the 2 angles is 90 degree, then we can say that the 2 angles are complementary to each other. But in this case, if ABCD is a cyclic quadrilateral, then the opposite angles of a cyclic quadrilateral are supplementary. That is, sum of the opposite angles of a cyclic quadrilateral are supplementary. That is, what is the opposite angle of A? That is angle C. That is, angle A plus angle C is equal to what? It is 180 degree. You know that, isn't it? Again, what is the opposite angle of B? That is angle D. That is angle B plus angle D is also 180 degree. That is, this theorem is done in class 10. Prove that the opposite angles of a cyclic quadrilateral are supplementary. What is the meaning of supplementary angles? If the sum of the two angles is 180 degree, then the two angles are said to be supplementary to each other. I think you have understood it. Okay. So now let's do this problem now. So here what is given? ABCD are the four angles of a cyclic quadrilateral taken in order. You have to prove that tan A plus tan B plus tan C plus tan D is equal to 0. Okay. So what is the condition given out here? ABCD are the four angles. Taken in order of a cyclic quadrilateral. Okay, so you can understand it from the figure also. So what can you write here? That is, the opposite angle of A will be C. That is A plus C. You can write only A plus C out here. That is, angle A plus angle C is equal to what? 180 degree. And what is angle B plus angle D is equal to, this is also 180 degree. So from here, from these two relations, let us get the value for A as well as B. What is the value for A from here? It is 180 degree minus B. And what is the value for angle B, which is equal to 180 degree? Sorry, this is angle A is equal to, this one is A is equal to 180 minus C. And what is this? What is angle B is equal to 180 degree minus D. Okay. So we have got the values of both angle A as well as angle B. So let us put these values on the left hand side. Okay. Let us put the values of A and B on the left hand side. So this is LHS is equal to tan A plus tan B plus tan C plus tan D. So let us put the value for A. What is the value for A? Tan, this is 180 degree minus C plus tan, what is B out here? It is 180 degree minus D. Okay, then write down plus tan C plus tan C plus tan D. Is that clear to all of you? I think you have understood it. So let us write down the formula first. What is tan 180 minus C? You know that 180 minus C lies in the second quadrant. In the second quadrant, tan is always minus. And since this is 90 to 2, E1 multiplied 90, so tan remains as it is. That is minus tan C. Similarly, what is tan 180 minus D? Minus tan D, you know that, isn't it? Then plus, you should write here tan C plus tan D. Is it understood now? So we can cancel here minus tan C plus tan C minus tan D plus tan D, which is equal to 0. So it is proved. Is that understood now? So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 2 of number 7. So here the given condition is the same as before. So here the given condition is if A, B, C and D are the four angles of a cyclic quadrilateral taken in order. You have to prove this result, that is LHS is equal to RHS, that is cos of 180 minus A plus cos of 180 plus B plus cos of 180 plus C minus sine of 90 plus D is equal to 0. So what is given in the question? A, B, C and D are the four angles of a cyclic quadrilateral taken in order. So from here what can you write? the sum of the opposite angles of a cyclic quadrilateral are supplementary. That is, you can write A plus C is equal to 180 degree and B plus D is equal to 180 degree. Okay, so let us write it now. Since A, B, C and D are the four angles of a cyclic quadrilateral, taken in order. Cyclic quadrilateral taken in order. Okay, so we can write sum of the opposite angles. That is, the opposite angle of A will be C. Their sum is equal to what? 180 degree. Again, what is the opposite angle of B? It is D. What is their summation? That is B plus D is equal to 180 degree. Is it clear now? Next, from here get the value for A. It is 180 degree minus C. And from here get the value for B. It is 180 degree minus D. Okay. So we have got both the values of A as well as B. Now let us prove this LHS is equal to RHS. So now let us write LHS is equal to cos 180 degree minus A plus cos 180 degree plus B plus cos 180 degree plus C minus this is sine of 90 degree plus D. Okay, so let us find out the value of this left hand side now. Now first of all you have to use the formula for all these terms. What is the formula for cos 180 minus A? Now you know that 180 minus A lies in the second quadrant. In the second quadrant cos is always negative, and 90 into 2 even multiple of 90. 180 is even multiple of 90, so cos remains same, so minus cos A. Similarly, what is 180 plus B? Lies in the third quadrant. Cos is negative here, cos remains as it is since 180 is even multiple of 90, so it is cos B. Similarly, what is cos 180 plus C? This is also minus cos C. And what is the last one? What is this sine 90 plus theta? Lies in the second quadrant. In the second quadrant, sine is always positive, but there is minus sign. So plus and minus is minus, and 90 into 1 odd multiple of 90, so sine changes to cos. So it is minus cos D. Is that clear? First of all, you have to use the formula. Okay, so minus cos A, minus cos B, minus cos C, minus cos D. So now let us put the values of A as well as B. So which is equal to minus cos of, what is A out here? It is 180 minus C minus cos of, what is B? It is 180 degree minus D, right? Then minus cos C minus cos D. So I think you have understood it. So let us use the formula. Again, what is cos 180 minus C? Minus cos C, isn't it? So minus into minus plus, it is cos C. Similarly, what is cos 180 minus D? Minus cos D, that is the formula. Now you know that. So minus into minus plus. So it is plus cos D, then minus cos C minus cos D. So you can cancel this. Cos C gets cancels. Cos D gets cancels, which is equal to 0. Proved. So this is the answer. So you can copy it. I think you have understood it. So now we'll do the next problem. So now next problem will be done, that is question number 4. Now 7 number 4 will be done out here. Now 7 number 3 will be a homework. The given is if ABC and D are the four angles of a cyclic quadrilateral taken in order, you have to prove this number 3, cos A plus cos B plus cos C plus cos D is equal to 0. I will not give you the hint. You can do it at home. Okay. So let's do this question number 4. Given here is the same condition. If A, B, C and D are the 4 angles of a cyclic quadrilateral taken in order, then you have to prove this number 4. We'll do it here. That is, you have to prove that tan of A plus B plus tan of C plus D is equal to 0. So let us do it out here. Okay. So this number 4, we'll do it here now. Number 4 will be done here. Since A, B, C and D are the 4 angles of a cyclic quadrilateral taken in order. So therefore, what can you write? The opposite angle of A will be C. That is, the sum of the opposite angles of a cyclic quadrilateral are supplementary. That is, A plus C is equal to 180 degree. And again, B plus D is also 180 degree. That is, B plus D is also 180 degree. You know that, isn't it? Next, so let us get the value for A from here. What is A is equal to 180 degree minus C. And what is the value for B from here? It is 180 degree minus D. So let us get the values of both A as well as B. Now you prove this LHS is equal to RHS. Okay. So now what is left hand side here now? So LHS is equal to, this is tan of A plus B plus tan of C plus D. Right. So let us put the value for A and B first, which is equal to tan within bracket. What is A? A is 180 minus C plus what is B? 180 degree minus D. Then tan of C plus D remains as it is, right? Tan of C plus D, which is equal to tan of, let us write it within second bracket, 180 plus 180. You know that this is 360 degree, minus is taken common. So minus C minus D, minus is taken common out here. So it is C plus D, second bracket closed, plus this is tan of C plus D. So I think you have understood it. Okay. So which is equal to now, what is this tan 360 minus theta? What is tan 360 minus theta? It is minus tan theta, isn't it? 360 degree minus theta always lies in the 4th quadrant. Whatever may be the angle here, take it as theta. So 360 minus theta always lies in the 4th quadrant. And in the 4th quadrant, tan is always minus, negative. Okay. Since 360 is 90 into 4, even multiple of 90, so trigonometrical ratios do not change. So tan remains same. That is minus tan of C plus D. Okay. So what is the second term out here? Plus tan of C plus D. So we can cancel them. So which is equal to 0. So it is proved. So I think you have understood it. So you can do it at home. That is 7 number 3 is your homework. Okay. So you can copy it. I think you have understood it. त आज हामीले कतिवटा प्रब्लम्सहरु गर्यौं हैन यो सबै प्रब्लम्स घरमा राम्रोसँग रिभिजन गर्नु यु क्यान रिभाइज इट एट होम so in the next online class we will do more problems on this trigonometrical ratios of associated angles so this much is for today so you can revise all the problems that we did so far okay